Hello guys, welcome back to Maison African Motives, still on mathematics and for revisions. So in this platform, we shall be focusing on question number 3 from the question paper of August 2021. So it did a mix of questions, the sketching of graphs, the solving of equations, exponential equations, and so forth. So we shall quickly rush through the questions so that we see how we're supposed to attempt these questions. So given the first part, to sketch the graph of xy is equivalent to 10, just to sketch. Okay. So on sketching the graphs, guys, I always advise you to just know a basic from your mathematics N3 revisions. They say do not just neglect that mathematics N3 concept. Okay. Anyways, let us quickly rush through this. That's xy is equivalent to 10. So this is question 3.1 where we are given xy equal to 10. So we know that we can actually write this inverse graph in terms of y in terms of x. So we can just divide by x both sides by x both sides. So y is equivalent to 10 over x. Okay, so this is another format that you can have, okay? Using this format is still one and the same thing. We know that xy, when it is a positive, okay, if you are given this in this format, if xy is equal to a, which is a positive, then the shape of the graph that you're going to have is going to be like this in the positive and in the first and third quadrant. If your xy is equivalent to negative a, then we are going to have our graph like this in this quadrant and also in that quadrant. So in this case, we are given that our xy is equivalent to 10. So that means we are going to have it the same way as it is when it is a positive, okay? So that's your x here, your y there. So we are going to have at 0. So as we saw the shape, so we're going to have the same shape as it tends to approach y. Also here, it tends to be approaching what? To be approaching x. The same thing on the negative, it will be tending to approach x and tending to approach y like that. So we are having the x-axis as the asymptote and the y-axis also as the asymptote. That's what you're having in this case. All right. So that was question 3.1 where we are given to just sketch. Okay, 3.11. We are now given is the graph of xy is equal to 10 asymmetrical or symmetrical about the x-axis. Okay, so can you divide this graph into two equal parts about the x-axis? Right, that's not, it's not asymmetrical, it's not symmetrical because you can't cover up. Okay, if I say symmetrical is like this, guys, I've got a function like this. If I am to divide this into two that is being symmetrical, that this half is going to cover up this half, but it's not happening according to the x. This half is going this way, this half is going that way. So that actually does not work. So which means this is asymmetrical. Okay, so 3.11, that is going to be asymmetrical. All right. Then we have got 3.12 is the graph of xy is equal to 10 continuous or discontinuous. So as you can see, guys, just checking this one, it's a discontinuous because it does not, okay, if we are referring to a continuous functions like this, it continues throughout, okay, or it's like this, it's a continuation one, it's a continuation type graph, okay, but these points, we've got asymptotes here. This point and this point are not connected together, so it's not continuous. So if it is not continuous, that means that's a discontinuous. So this is going to be discontinuous. All right. So that was question 3.12. On 3.2, we are now given now to sketch the graph of x is equivalent to 2 to the exponent of negative y. So like I was saying, just knowing a basic information of how your graphs are supposed to look like from your maths N3, it helps. Okay, so let's just have our sketch. I'm just going to remove this part here. So let's just remove these. Okay, so that's 3.2. Right, like this. So on 3.2, guys, we are given x is equivalent to 2 to the exponent of negative y, like that. Okay, so it's either you can make y to be the subject by your inverse functions, logarithms, and so forth, or just knowing the sketch that if you are to find for every value of y that you're going to have in this case, okay, as you substitute the values of x, okay, as you substitute the values of x that you're going to have, which means y is going to decrease. As the values of x increase, y is what? Y is decreasing. That's like inverse. Y is a negative here. So as x increases, okay, as x increases here, y decreases. Okay, and at a condition that y is equal to 0 there, which means our x is at a condition, if you substitute y being a 0 here, it means x is going to be 2 to the exponent of 0, which means x is going to be 1 at that moment. So which means the graph that we are talking about is actually on the right-hand side. So we're having our graph from the right-hand side like this. This is our x and our y. So we have a solution or a root that is found in the x-axis. But there is no condition that we are going to have because x cannot be equal to 0. So which means at x is equal to 0, which means in the y-axis, it's an asymptote. So that is what you're going to have in this case. Okay, so your graph, as we say, this is an asymptote. So our graph is going to be like this. It decreases, passes through 1, 0 there. It decreases as it goes. The values of x are increasing, y is decreasing, and so on and so on and so on. All right. So that is the graph that you're going to have. That's x is equal to 2 to the exponent of negative y. Okay. So 3.21 was to, okay, 3.21 is the graph of x is equivalent to 2e to the exponent of negative y, continuous or discontinuous. Okay, so let's check. It's just a single function that we have and it's connected throughout. So that's a continuous function. Okay, so 3.21, this was going to be a continuous function. All right. Then we move on to question 3.3. Okay. So on 3.3, we are now given to sketch the graph of y is equivalent to cot x from negative 360 up to positive 360. So you see now the advantage, guys, of knowing these graphs. It doesn't take you time. There's no need for you to draw even a table of values there. You are sketching here. They expect you to know the same way you know the graph of sine x, the same way you know how the graph of cos is supposed to look like, is the same way you're supposed to know all these trig functions and even the one for cot. Okay, so 3.3, that's y is equal to cot. Okay, that's cot of x taken from minus 360 up to positive 360. All right, so which means our values of x, they are going to be from negative 360, right? This is too much, guys. This is too much. Let's just see if I can try to redo this one. All right, so something like this. All right, so we are going to take our values from negative 360. So we are going to separate this by 90 degrees. So we've got negative 360, negative 270, negative 180, negative 90, is 0. Then we've got 90 and so on, 180, 270, 360. Your angles each separated by 90 degrees. And we know that in this case, this will be your y-axis. Okay. So from the sketch that we have, if it is a chord, we must indicate first the asymptotes. Okay, so our asymptotes, they are at negative 360, negative 360 here. That's actually an asymptote there. All right, so let's use this one. So we have got an asymptote here, another asymptote at negative 180, another asymptote in the y-axis, so it's an asymptote again. All right, then at positive 180 is an asymptote again. At 360, it's an asymptote again. All right, So that means our graph is going to be found in between, but we know that at 270, that's a 0. So our graph is going to be like this. So like I was saying, guys, you must know these graphs, how they look like. Yes, you can try to figure out from a table, this and that, but just know the shape. Okay. The same thing here passes through negative 90, then it won't approach the y-axis because that's their asymptote. Okay. So take note, guys, this is our x here, and this is our y. At y is equal to 0, it's an asymptote, but it passes through 90. So it's going to pass through 90 like that. Okay. 180 is an asymptote, 360 an asymptote. So it's going to be passing through 270 like that. Okay, it won't pass the 360. So this is what we are going to have as the graph of y is equivalent to the chord of x. All right, so more questions, guys. You have to revise more questions as much as we can. 3.4, solve for x. Okay, so take note, is one of the other questions also that they did wrong there, because here we are given, okay, let me write the question, how it is actually given. So that's question 3.4. I'm just going to remove this part here. All right, so on 3.4, guys, we are given to find the value of x, or to solve for x, if 3 to the exponent of 2x plus 1 is equivalent to ln, and there is a ln of 3 like this. All right, take note of what you are given there. There is a ln already and another ln. Okay, so we know that if we are solving this equation, we are supposed to introduce ln into the equation. So the moment you introduce ln, take this ln is for solving, or for this exponent that we have 3 to the exponent of 2x plus 1. So that from our laws of exponents, we are going to drop from our laws of logarithm, we can drop the exponent down. That's 2x plus 1 ln of 3, which is equivalent. Now on this side, we have got ln, and there is another ln that we have, and we've got ln of 3. So this is what we are going to have at the end. So it's ln of ln 3. Take note, they are not 2, they are going to be 3, because this ln is for the introduction when you are to solve for that one. Okay, so now we can divide by ln of 3 both sides, by ln of 3 both sides. So this can cancel. So 2x plus 1 is equivalent. Ln of ln 3 is going to give us something like negative 2, 364. Okay, let's just share. Let me just share the screen here so that we can see everything on the screen. All right, so it was supposed to be ln, then inside the bracket it's a ln, then inside that it's a ln of 3. So we're going to close the bracket of ln 3. We close the bracket for that ln. We close the bracket for the first ln that we had. So we are going to obtain negative 2, 3. Whatever that we have here, we are supposed to divide by the ln of 2. So take this ln 3, okay? So let us just divide direct by ln of 3 like this. So that's negative 2,152. Okay, so here let's just write the final answer, not the one of dividing both. We are going to divide again by ln 3. Okay, so let's just write the resultant as it is. So this is going to be negative 2,152. Okay, negative 2,152, because that 7 is going to change. We transpose the positive 1 to the other side of the equation. As you can see, it's a positive. So once transposed, it's going to be a negative 1. So that means we've got negative 2, what that we have, then minus 1, which is going to be negative 3,152. So to find x, we divide by 2 both sides. So our x in this case is going to be negative 3. That's from your calculator there. So just insert your calculator. That's negative 3,152 divide by 2, which is going to be negative 1,5. Okay, that was 1576. All right, so this is the value of x that you're going to have at the end. So please, there is any other way that you think of, then let's know, guys. We can work from there. All right, on 3.5, we're now given to expand to 4 terms. All right, what are we given there? What are we expanding? Which method are we using? So we are now on the binomial theorem. Okay, so I'm going to rewrite the question. And guys, for binomial theorem, we just need to know the stages and how to use the formula. Okay, so it was given on 3.5. Okay, so I'm just gonna take down the question as it was. Then we work it from the scratch. So that was x minus 2 to the exponent of 3 over 4. All right, so we've got something like this. X minus 3 over 2 to the exponent of 3 over 4. So remember that your binomial theorem, guys, states that if you are given an, let's say we've got x plus h to the exponent of n. This is going to be x to the exponent of n plus n, x to the exponent of minus 1. That's okay, that's x to the exponent of negative 1. Then we've got h here to the exponent of 1 over 1 factorial. All right. Then plus, you drop the exponent again. So it's n by n minus 1. Then h is increasing whilst x is still subtracting 1. So it's now n minus 2, h to the exponent of 2 now over 2 factorial. So if you can write in terms of x plus, it's easier. So you can just try to avoid the plus and rewrite this question as x plus minus 3 over 2 like this to the exponent of 3 over 4. So that means we have got our x here, we have got our h here. So what is the question actually referring to? We are seeing that the first part is x to the exponent of n, which is in x to the exponent of what? The exponent, which is 3 over 4. So that's x to the exponent of 3 over 4. Okay, plus we drop the exponent that we have, which is n, we subtract 1, just like the derivative. All right. So if we drop the exponent, the 3 over 4 down, it is going to be 3 over 4. X to the exponent, you subtract 1. Okay, so that's 3 over 4 minus 1, which is going to give us negative 1 over 4. So that's negative 1 over 4. All right. Then the minus 3 over 2 starts to appear just like h. So we are now having negative 3 over 2 over 1 factorial, of which 1 factorial, there's no effect, guys. You do the same thing. All right. So here we are at a point where we've got plus, we drop the exponent, so it's 3 over 4, which was already there, times, if you drop the exponent, which is negative 1 over 4, it's going to be negative 1 over 4. But the moment you drop the exponent, take note what you're supposed to do. You subtract 1. So it's negative 1 over 4, negative 1, which is negative 5 over 4. All right. Then the minus 2 is increasing, just like h. It's now h squared. So it's negative 3 over 2 squared. Now everything over 2 factorial. Okay, we move on to the other part. Remember, we said up to 4 terms. So this is the first term, the second term, third term. So let's take the fourth term. We do the same here. We drop the exponent 3 over 4 times negative 1 over 4. Then we drop the exponent of negative 5 over 4. So it's going to be negative 5 over 4. The moment you drop this exponent, you are subtracting 1. So negative 5 over 4, negative 1, that's negative 9 over 4 from your calculator. Then h, as we saw, it was increasing. It was at 2, which means you're going to see it at 3 over 3 factorial. So the minus 3 over 2 is increasing. So it is going to be minus 3 over 2 to the exponent of 3, everything over 3 factorial. Okay, so these are now 4 terms. We can simplify further. All right, so x to the exponent of 3 over 4 is going to be x to the exponent of 3 over 4 there. Then the numbers here we can multiply. So on your calculator, you are simplifying this part, 3 over 4 times minus 3 over 2. Okay, so let's see if the screen is still showing everything. Okay, the screen is still showing everything. So if you use your calculator here, we are going to have, it was 3 over 4, so that's 3 over 4 like this. Whatever that we have, we multiply to negative 3 over 2 like this. So this is going to be negative 9 over 8. All right, so we are going to obtain negative 9 over 8, x to the exponent of negative 1 over 4. All right, you do the same thing on this part. You simplify the part, so you just have to introduce or to have a fraction here. All right, so let's see if we have to put a fraction. That's 3 over 4, right? 3 over 4 multiplied to negative 1 over 4. So that's negative 1 over 4. Then we multiply this negative 3 over 2 in bracket squared. So we are going to multiply, just open a bracket, negative 3 over 2. Then we square that bracket, okay? So that's squared over 2 factorial. So 2 factorial is shift. You go to the factorial there, which is going to be negative 27 over 128. All right, so we are going to obtain negative 27 over 128. Okay, then x is still at negative 5 over 4. So you can just write it as it is. All right, we move on to the other part. We simplify again, just like what we saw previously. So this is going to be a fraction again. We've got 3 over 4. So that's 3 over 4 multiplied to negative 5 over 4. So that was negative 5 over 4 like this. Multiplied to, that's negative 3 over 2. So we've got negative 3 over 2 like this. All right, let's put the 2 here. Negative 3 over 2, then we've got to the exponent of 3. All right, now it's over 3 factorial, so it's 3, then the factorial there, 3, which is going to be 135 over 2 something. Okay, so let's see if everything is properly given. Negative 4, we do not have the negative 1 over 4 there. I left the negative 1 between 3 over 4 here. Take note, is 3 over 4 by negative 1 over 4. Okay, so we need the negative 1 over 4 there. So that was times negative 1 over 4. All right, then times this, which is negative 135 over, is this what I'm supposed to have? Or I'm doing it another way now? All right, let's just do it together because already there I saw something there. So that's 3 over 4. Okay, so for 3 over 4 multiplied to negative 1 over 4. All right, that's negative 1 over 4 times negative 5 over 4. Okay, so it's times negative 5 over 4 like this, times this part, negative 3 over 2 to the exponent of 3. So it's times negative 3 over 2 like this to the exponent of 3. Then everything over 3 factorial, that is going to be 3 factorial like this. So it's negative 135 over 1024. All right, so that's what we are actually having. Okay, that's what we are actually having. I think we have tried to rewrite this now and again. We are still doing the same thing. 135 over 1000, and that's 1024. Okay, 1024. Then it's x to the exponent of negative 9 over 4. Okay. So what you're going to do in this case is to simplify. We can apply our exponents. Okay, we know that from our exponents, x to the exponent of m over n, if it is x to the exponent of m over n, that's the nth root of x to the exponent of m. All right, if it is a negative, you remove the negative, it's 1 over. So here we are supposed to obtain this because that's our m and n. So it's supposed to be the 4th root of x to the exponent of 3, okay? Minus here, it was supposed to be minus 9 over. To remove the negative, it's 1 over. But the moment it's down, it's 8 x to the exponent of 1 over 4, which is the fourth root. So it's 8, the fourth root of 4 with respect to x. Negative 27 over 128. Okay, we do the same 1 over. So it's going to be x to the exponent of 5 over 4, which is the fourth root of x to the exponent of 5 minus 135 over 1024. We drop this one, is like just all these numbers. So it will be x to the exponent of 9 over 4, which is the same as the fourth root here because it's 9 over 4. So it's going to be the fourth root of x to the exponent of 9. So if there are any errors or any part that you see that is not clear, maybe, you know, numbers, guys, you can just substitute something in a wrong way or something like that. So let me know if they are such, so that we can revise these questions again in another class, correcting those errors that we have indicated or that we have seen. So for this question 3 from August 2021, that's what we had, guys, from Meson African motifs. Till we meet again.